Greetings, dear children. So, today we are going to start with the topic ligands. Like yesterday, we had discussed about the introduction of coordination compounds. So, today we'll understand what are ligands. As discussed yesterday, ligands are nothing but Lewis bases. So, the right definition which you will give in the board examination will be ligands are ions or molecules that can donate a pair of electrons to the central metal atom or ion to form which bond? A coordinate bond. This is important. This bond. Yesterday, we had discussed about this. Now, what are the types of ligands? There can be different types of ligands, like depending upon their capacity of how many electron pairs they can donate, or depending upon the charge on them, whether they are negative, positive, neutral, etc. Okay, so the types of ligands, first we have the monodentate ligands. As the name suggests, mono means one. So these ligands have only one donor atom. Okay, and they can attach to the central metal atom or ion through only one coordinate bond. The best examples which we have written here is ammonia. Now, ammonia is not called as ammonia in the compound. When you're making a coordination compound of this, you will be writing it as amine. It is a neutral ligand. As you can see, it has a charge of 0. Next is water. Water has got oxygen as a donor atom. Now, oxygen, you can see it has got two lone pair of electrons, but at one time it can just give one pair of electrons. So it is also monodentate and it is neutral. So, however, you writing water in the coordination compound, its name will be written as aqua. The third is Cl minus. Now, Cl minus is nothing but chloride. It is monodentate because it can just donate one lone pair of electron, unshared pair of electron to you, and it is a negatively charged ligand. Okay, so it is known as chlorido. Then cyanide, it is cyanido. It is again monodentate. OH minus, that is hydroxide. So it will be called as hydroxido. So this is also going to be negatively charged. So this is monodentate ligand. The ligands which can donate only one electron pair. Those which have only one donor atom and they can donate only one electron pair. Then we have the second one, that is the bidentate ligands. So what are bidentate ligands? So naturally the bidentate ligands will be the ones which have got the two atoms to donate the electrons. So they have two donor atoms and they can form how many coordinate bonds? Two coordinate bonds. Example, the best example here is C2O4 minus 2. So I'll just show you how does it look like, because this is important for us to understand. Otherwise we just understand the name of the structure, we do not know how does it actually look like. So I have drawn presently in front of you C2O4 minus 2, that is nothing but oxalate, and it is going to be known as oxalato. So here it's written that how you're going to name it in the coordination compound. So it's called oxalato. Now you can see it has got two lone pairs, two unshared pair of electrons. So these are the donors. Oxygens are the donors. So from this side as well as from this side. So these are the two sides from where you're going to give the electron. So this is one donor atom and this is another donor atom. So all the ligands which have two donor atoms and which can donate two electron pairs will be called as bidentate ligands. Naturally, polydentate ligands. So polydentate ligands, as the name suggests, poly means many. So the ligands that can form more than two coordinate bonds, okay, they are called as polydentate ligands. So more than two. Example is EDTA. Now what is EDTA? EDTA is ethylene diamine tetraacetate. Okay, but when we write it in the as a ligand, we will be writing ethylene diamine tetraacetato. So all the negatively charged ligands, their names are going to be ending with OOO kind of things. Like chloride will be chlorido, bromide bromido, fluoride will be called as fluorido, oxalate will be called as oxalato. So ethylene diamine tetraacetate is going to be called as diamine tetraacetato. Okay. Now, how would ethylene diamine tetraacetato look like? And in the exam, they have also asked questions on draw the structure of EDTA. So it's very simple. Now, see, its name is ethylene diamine tetraacetate. So first you draw ethylene diamine. So how would it look like this? So you first draw ethylene skeleton, then you draw diamine. That means you have to draw hydrogens, nitrogen and hydrogens. So this is your ethylene diamine, ethane 1,2 diamine. Okay, now it is tetraacetato. So what you have to do here is you have to actually remove these hydrogens, and what you will draw here is 1, 2, 3, 4. So you have to draw here CH2, C double bond O minus, CH2, C double bond O minus, On this side also you have to draw the same thing, that is CH2, C double bond O minus, and also on that side CH2, C double bond O minus. So basically, you are going to draw acetates. Okay, how many acetates you have drawn? Four. First, second, third, fourth. Remember this. It's very simple. Okay, practice this, please. So this is ethane diamine tetraacetate, but we call it as ethylene diamine tetraacetate, and we have a total six donor atoms in this ligand, which are the six sites. So I'll just label it. This is the first one, that means from here. This is the second one, from here. The third one, that's from this oxygen. The fourth one is, that is from that oxygen. Then on nitrogen there is one lone pair, this is the fifth position, and another nitrogen, sixth one. Okay, so ethylene diamine tetraacetate is a hexadentate ligand. Got it? Okay. After this, in the next video, we'll see how to write the formula and draw the structure of some compounds. Thank you. Take care.